Hello, everyone. I'm Frank. Apologies for that. My chair just makes sounds now. I don't know. Try not to move too much, but anyways, um, I'm Frank, and welcome to Frank Puzzles. And this is today's challenging level puzzle, and it's called Quadroppelgänger by Math Guide 12. And here are the rules. We have quad doppelganger Sudoku, where we need to fill each cell of the four 4x4 grids such that every row, column, and 2x2 box contains a 0 and three different digits from 1 through 4. Within a 4x4, no two rows, no two columns, and no two boxes may be missing the same digit. And for each 0, the digit missing in its row, column, and box must be three different digits. Okay. Fill each cell between 4x4s with the digit missing from the corresponding row or column. So they must be missing the same digit in those columns and rows then, I guess. Huh. Right, so fill each cell between the 4x4s with a digit missing from the corresponding row. So therefore, this digit must be missing the same digit in this row and that row from 1 through 4. Fill each cell in the central 2x2 with the digit missing from the corresponding box. So these digits that are missing in the boxes must be the same for all four grids. Orthogonally adjacent grids share the same missing digits from either. Okay, so that explains it, yeah. Orthogonally adjacent grids share the same missing digit from either the rows or columns. For example, northwest. Wait, why is east and west swapped? I'm so confused by that. Anyways, usually it was west, north, south, east, and south. But here we have actually, if you take a look, we have east on the left side and west on the right side, which is very weird. Huh. Okay. For example, northwest, which I guess in this case is here, and northeast, which I guess in this case is here, grids have the same digits missing from the rows, right? And all grids share the same missing digits from boxes. So the upper left box in all four grids are missing the same digits, same as the upper right box, which is missing four digits there. Interesting. Digits along an arrow sum to the digit in the arrow's bulb. So therefore, for example, these three digits must add up to what this digit is. These three digits must add up to what this digit is. These three digits here must add up to what that digit is, etc., etc. And cells without digits do not affect the clue. Right, so there's nothing, this doesn't affect anything, right? It's just basically to show where this points to. So for example, you could have, say, 0, 2, and 1 here, and this would have to be a 3 if that were the case. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these two digits must add up to what that digit is. We have 1 through 4 available in the extra rows and columns here, and the extra square here. So it has to be at minimum 1 and 2 here. So this is either going to, and these are all 4 unique digits because each box must be missing a unique digit. So this is either 1 and 2 or it's 1 and 3. Either way, we are guaranteed a 1 here. Because again, these have to be unique digits. So this is then 3 or 4. That means if this is 1, 2, this has to be a 3, 4 pair. If this is 1, 3, this is a 2, 4 pair. Can this ever be 2? I think the answer to that is no, right? Because these are going to be 3. So every set of 5 digits in a grid, including the ones that are missing, must be the digits 0 through 4. So this is at best 0, 1, 2. This has to be 3 unique digits. So therefore, we are guaranteed a 0 here. And yeah, that's for any combination. Therefore, we has to be 0 here. This is 0 here. This is 0 here. Because 1, 2, and 3 at minimum adds up to 6, right? So we have 0 here. One of these. So for every one of these, this is 0. So let's highlight where 0 cannot be in these rows and columns. 0 can't be here. 0 can't be here. 0 can't be here. 0 can't be one of those two. 0 cannot be here. So it's going to be 0, 1, and 2 at minimum. So all of these circles are then 3 or 4. And that also applies here. This cannot be 2 here. So we're missing 3 or 4 there. We have to have 0 here. We have to have 1 here. So... Right, so every 3... These are going to be all 3 unique digits no matter what. For all of these. This is the only different one. So this can never be 0 or 1. So all the blue cells have to be 2, 3, or 4. And 4 can never be any of these digits. So we're guaranteed a 4 here. 4 could be one of these two, though. So this has to be 4 here. Hmm. Hold up. Okay, so for any set of 3 digits, it's going to be 0, 1, 2 or 0, 1, 3. If it's 0, 1, 2, this must add up to 3. So if this is 0, 1, 2, this is 3, and then this is 4. So I think for all the singleton blue cells, they have to be, well, not obviously this one. All the ones that are not part of the arrow, this is either going, if this is 0, 1, 2, that's 3, and this is 4. If this is 0, 1, 3, this is 4, and then this is 2. So this is going to have to be 2 and 4 in all the singleton blue cells. This obviously could be, has to have 4 here, and it's either 2 or 3 with it. Okay. What does that tell us? I'm not really sure. Right, we know this is 0 and... Oh, this... Well, one of these is 1. So one of these 3 is a 1. One of these 3 is Obviously 1. One of these 3 is 1. One of these 3 is 1. Okay. What does that imply, though? Okay, so what happens if this is 4? If this is 4, we cannot be missing... Well, we don't know. This has to be 2, 1, and 3, which eliminates 1, 3 in the rest of the boxes for these. So this must be 4. We must be missing 2. So we're missing 4 in this lower right-hand box. We cannot be missing 4 then in one of rows 1 and 2 ever. So therefore, and it cannot be missing 4 in one of rows columns 1 and 2. So therefore, this would be 3. This would be 0, 1, 2, adding up to 3. This would be 4. This would also be 3, so it would have 3, 0, 1, 2, and this would be 4. 4 has to be missing from box 4, so this can't be 4. So that would be 2. So this would be 0, 1, 3, adding up to 4 there. So we're missing a 4 in this column here. We're missing a 4 in this row, so therefore this would be 2. Or this box. So this would be 2, which would force this to be 4. 0, 1, 3. 2 would eliminate 2 from being here. That looks fine. So then this would have to be 0, 1, or 3, with the 0 guaranteed here, because we're missing in the upper right-hand boxes 1 or 3. So this cannot be 1, 3 here and 0 here. So this would be 0, 1, 3, and this would be 1 or 3. This is 4, so it cannot be 2 in any of these cells. So then this must be 2 and 4 here. We're missing either 1 or 3 here. Where are we missing 2 in that column then? It would have to be here. So far this is looking fine. I don't know. 2's missing there. 2's missing here. This is 1, 4 as a pair. This can't be missing a 4, so it's missing 1, which makes that 4. So far this is looking fine. This would be not 2, so this is 0, 1. You have 0, 1, 2 there. This is 0, 1, 3. We cannot have 1, 3 in both of these cells because we're missing a 1, 3 in the lower left box. So therefore, this is 1, 3 here and 0, 1, 3 there. This again would be 0, 1, 2. No 2. We're missing a 2 here. We're missing 1 here. So this would be missing 1 or 3. We're missing 2 in the top cells. So this must be missing 2 there. We're missing 3 here. So therefore this would be 3 and that would be 1. Interesting. So then this would be 0, 1 as a pair, which would force this to be 3. We're missing 1 and 4 here. We cannot be missing the 4 here, so that's 1 and 4 there. We're missing 4 from here and 4 from here. So we're not missing a 4 here or here, so that would be 4 there then. This would be 0, 1, or 3. We're missing a 3 here. This is 0, 1 as a pair. Therefore, we have to have 2, 4 here. This can't be 2 because we're missing a 2 in that column, so it's 4, that's 2. This is looking like the solution, unfortunately. Um, huh. Hmm. We must be missing 2 and 3 at the top. So this is 2, 3 as a pair. This is 1 missing. Okay. Yeah, this is looking like a potential solution. It's not, I'm not getting any contradictions here. So then let's try going the other path. Uh, this is all still the same. So if this were 3, this would have to be not 1 and 3, it's 1 and 2, which means this can't be 2. Um, maybe. Let's go not that assumption. Let's assume this is 3 then. That does the same thing, which forces this to be 1, 2, which adds up to 3 there. But that gives us more clarity about this. So we're missing 4 in the top row and 3 in the bottom. So this can't be... in the top 2 rows, we're missing a 4. In the bottom 2 rows, we're missing a 3. So this cannot be missing a 4, it's missing a 3. This can't be missing a 3, it's missing a 4. In columns 1 and 2, we're missing a 4. So that's 4. And in columns... in rows... Sorry. Yeah. No, in columns 3 and 4, we're missing a 3. So that's 3. So this would be 4 here, which means this is 0, 1, 3. Therefore, this is 2. So that's satisfied. Therefore, this is 2. 3 is missing here. 0, 1, 2 forces that to be 4. 0, 1, 2 forces that to be 4, so this can't be 4 here, so it's 4 there. This can't be 4 in that instance, so 4 has to be there. This is 0, 1, 3. This is 0. Okay, so I don't want the 0 and 1s to be all around. It's just, there's too many. Okay, 2, 4 is fine. Let's remove all the ones with zeros at the ends, and then remove that. So we already know that. So that was looking fine too. Huh. What happens if we make this a 2? Maybe make that. Oh, but we already tried that. It's in essence, right? Um. Hmm. 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 These have to be this. Okay. If this is 4, that means this is 2 and 2. What I'm thinking is, can these actually be the same or the different digits? Right now, we've had both of them be the same digit. Um, we have a guaranteed 3, 4 in one of the top two rows. We also have a guaranteed 3 or 4 in one of the bottom two rows. We have a guaranteed 3, 4 in one of columns 1 and 2. We have a guaranteed 3, 4 in one of columns 3 and 4. So this can never be 3. Hold up. What does that imply? Um, sorry. This is guaranteed missing digit, I should say. That means, can we ever have 3 and 4 be here in the same row, or the same missing in the same lower two boxes or right two boxes? So say we had 3 in here and 4 here. So 3 and 4 means 3 and 4 cannot be missing in the top two rows. But we are guaranteed a 3 or 4 missing in one of the top two rows. So this cannot be 3 because that would force us to be 4. Same with if we have 3 or 4 here. If we're missing a 3 in columns 3 and 4, and we're missing that same 4 in columns 3 and 4, this could never be then 3 or 4 missing. So this can't, neither of these can be 3. Because if we have 1, 3 here, that forces us to be 4. And we would either have 3 be missing in rows 3 and 4 with the 4, which would invalidate that cell, or we'd have 3 and 4 missing in columns 3 and 4, which would invalidate this cell. So this has to then be not 3, which makes us a 1-2 pair, which does force us to be 3. Therefore, this has to be 3 or 4 then. This must match this cell. So these two cells are the same, because this must be the missing digit in the column, which is equal to that missing digit here. It's also the same as that digit here. So these 3 digits are the same, because the one that we're missing in rows 1 and 2 must be that one, right? This, oh, unfortunately, well, this one must match these two. I guess we can make, let's make these, I guess. No, let's make these orange. No, let's make it yellow. We'll make it yellow. So these are yellow. That means these two digits that are missing are the same, but these have to be different from these two digits. So let's mark these as red. These are blue. We don't know which ones these are. Yellow cannot be missing from any of these cells. Obviously, it cannot be here. So yellow has to be one of these two digits here. Um, um, hmm. Yellow is missing from one of these 4 digits. Yellow is missing from here. So yellow has to be one of these two in box in the grid 1. Yellow can't be here or here. Yellow's missing from box, so yellow has to be one of these two. We are not missing yellow here. So therefore yellow has to be one of those two, or it could be any of these three here. Yellow's missing from here. Yellow's missing from here. Green. Green cannot be any of these, but it could be any of these three. Green can't be here. Oh no, green cannot be any of these. So green is one of these two. I guess we'll make this, I don't know, pink and this orange. So green is missing from one of these. It has to be one of these two cells. So this has to be missing orange because we're missing green and orange here. This must be missing pink because we're missing in columns 1 and 2, green and pink. This is a green-pink pair. This is missing orange. Bottom 2 is yellow and pink. Top 2 are green and orange missing. So this must be yellow and pink missing here. We know yellow has to be one of these two. Okay. We are not missing yellow in column 2 in this grid. So this must be yellow here. Orange cannot be either of these cells in row 2, so orange has to be one of these two. This has to be yellow and orange missing. Pink in column 1 here has to be one of these two. We also have zeros too, so I don't... So 0 in... on this line cannot be here because it would be missing the same digit in the row and in the column and the box. So this cannot be 0, which means 0 has to be one of these two digits here. And this 0, cool. The 0 on this arrow cannot be missing orange and orange in the same box. So 0 has to be here. Very cool, actually. That's really cool. Because then this 0 would be missing yellow, green, and orange, and that would be valid. That means 0 has to be one of these two cells. It cannot be, yeah, 0 cannot be here, so that forces this to be 0 there, which is missing orange, green, and it must be missing a non-green, so this is pink, which means this can't be pink, it's missing green. Very cool. 0 here. Cannot be missing green and green in the box and the row, so 0 has to be one of these two. 0 is missing green, and it's missing orange. Well, it could still be either of those, so that's unfortunately not helpful. 0 in this column is missing green and it's missing pink. 0 in this column is missing orange and it's missing... I don't know what else. 0 cannot be here because it would be missing green and green. So it has to be here, which means it's missing pink and green, which means it must miss yellow in the row. So that's 0. 0 cannot be missing yellow here, so it has to be here. So 0 is missing yellow in the row, pink in the box, so it must be missing green in the column. So that's 0. Hmm. Interesting. We know there's a 0 missing here. It cannot be missing yellow and yellow, which would be in the right-hand corner. So it has to be 0 here. We have a 0 in one of these. It's missing orange. 0 must be missing here. So it's missing pink and green, and therefore orange. Green is missing here. So it's not missing in box 3. So therefore, it has to be one of these two. So this is a yellow-green pair here. This cannot be pink, so this has to be orange here. So this is orange, this is pink. Orange and pink add up to 3. So therefore, all the yellows are 3. So we'll remove those. We'll move those. That's not helpful. So this is yellow, which means it cannot be green. So green has to be here. This is yellow, which means we're not missing yellow in column 4. Here we're missing orange. This is yellow there then. Let's remove these. And we'll move this. This is a yellow-green pair. This is a yellow-pink pair. So we'll move these. We know this is 3, which means the blue has to be 4. And the green is 4. This can't be 4, so this is not green. This is not yellow. So this is yellow here, which means we can't be missing yellow here. We're missing pink, which means we're missing yellow there. All the greens then are... Don't know what this is. All the greens are 4. And that makes the reds 2. All the yellows are 3. Okay. We don't. Okay, so this is 1, 2, 1, 2, 1, 2, 1, 2. So this cannot be the orange 1, 2. It has to be the pink one. So this is pink. This is orange then. We have orange here, orange here. We're missing pink here, so we have to have 0. Okay, so we're missing pink in the box. 0 cannot be matching that. So it's missing green, yellow, and pink. So therefore this is 0, which means 0 has to be here. This then is missing pink. Cannot be pink, so this is orange. This is missing yellow, so pink has to be there. We're missing 4 here. So where's 4? 4 has to be here in this upper right-hand box. We're missing orange, so that leaves this as yellow. In row 2, then we're missing pink. So that's pink there. This is missing green, so this is yellow. Orange is one of these two. We have to have a 0 here. The 0 is missing orange in the top right cell, so it cannot be here, so this is 0 here. We cannot be missing, so we have a 0 here. We're missing yellow and orange, so this can't be 0, so this is 0, which means it's missing pink. One of these is 0. It's missing 4, so it has to be 0 there to be not missing the same digit. That leaves us as a 0 here. Okay. We're missing 0 here and 0 here. Okay. Do we have any from... This has to be pink or orange. And this can't be pink because we're missing that. So this is orange. This is pink. In row... So blue is green. And 2, we don't know what the reds are. So that's going to have to be whatever. 3 is yellow. And we're missing the orange. So this is pink. Which means this is pink. So this cannot be pink here. So this has to be orange, which means this is not orange. So orange is the 2. Okay, let's just continue with this. This is pink, this is orange, this must be yellow. We're missing in column 1 a yellow, so this is yellow. In column 2, we're missing green and orange. This is green, orange as a pair. We don't know which. Column 4, we're missing green. So this is green, which means this can't be green. So that's orange, which makes that green there. That leaves the remaining digit missing in row 3 here as pink. And then we're missing column in the box. We're missing an orange. Okay. This is 1 and 3 as a combination. 2 is orange. 0 cannot be here. 0 is one of these two. It's missing yellow. It can't be missing another yellow, so 0 has to be here. Okay. We're missing... So we have to have yellow and pink here. Pink cannot be in the lower left-hand box, so this is yellow, which makes this pink. Remaining digits of... We have to have orange in one of these two cells. We don't know which it is. We're missing in box 4 here a orange, so that's orange there. In box 3, we are missing green and yellow. This can't be green because of green missing in the column, so this is green, that's yellow there. We are missing a 0 and a yellow here. We don't know which of those are. Here, we're missing pink. That doesn't help. We're missing a 0 here. And a green. Okay. Here we're missing... So this is 0 green. This has to be pink and yellow. Oh, this is orange, so this cannot be missing orange here. So that's missing green, which means this can't be missing green there. That's orange missing. And this should help us a lot. Green can't be here. So this is missing green, pink, orange, and yellow. So this is a 0. Right, the 0 match is missing the green in the row, the orange in the box, and the yellow in the column. That leaves this as a 0 here. In this 0, we are missing pink in the column, green in the box, so this cannot be 0 here, which makes that 0 there, which makes that 0. And then everything else should fill out pretty nicely. We're missing a green here, so this leaves that as yellow. In row 1, we have to have a pink left, so that's pink. In row 2, we are missing yellow and green. This is missing a yellow, so therefore this must be green. That's yellow there. Remaining column 4, this is green. We have to have pink and orange here. This can't be pink because we're missing a pink in that row, so this is orange. That's pink, which leaves this as orange there. And this has to be green here. Column 1 here, we're missing yellow, so that's yellow. Column 2, we're missing orange and pink. This can't be orange because of orange missing in the row. So that's pink, that's orange. Column 3, we're missing a green, so that's green. And then row 2, we're missing a yellow, so that's yellow. Row 1, we're missing a pink. And that's everything. So the pinks are 1. So we have 1 there. The oranges are 2. The yellows are 3. And the greens are 4. And that's how you solve it. Pretty cool, actually. It was interesting how that interacted. Particularly this break-in. That was very interesting because I didn't get that from just setting that to 4. We sort of had to basically logic our way through this to see, hey, if we have 3B1 of these, it would force 4 to be there, but that would mean we'd have 3 and 4 missing in either rows 3 and 4 or columns 3 and 4, but we know there's a 4 or 3 missing in one of rows 1 or 2 or one of column 1 and 2. So that forced this not to be 3 and 4 as a pair in any of these spaces, so therefore this had to be 3 and 4 there. And from that, we have the coloring, which worked. And then that gave us a coloring here, which was interesting. Pretty cool, actually. Pretty interesting. I mean, this is actually some of the sort of internal logic that you start getting the intuition of for the doppelganger puzzles. But it's still like, I don't know. I think doppelgangers are still pretty new in this, so it's kind of hard to figure out what sort of intuitions you have actually with these. But anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.